Welcome to this web lecture about direct manipulation in 3D, real, virtual, or augmented environments. Let us recall what direct manipulation is. There is a continuous representation of the objects we're working with and the actions we can perform using visual icons. The actions we can perform, we perform by dragging objects, by clicking on buttons, and we have no syntax to be concerned with. There are rapid, incremental, and reversible actions. And we see the effect on the objects directly, and if we don't like the effect, we can reverse it through an undo function. Now we're going to apply that in 3D worlds. There is pure 3D versus simplified interaction. In most cases, we will manipulate and simplify interaction a bit versus doing everything exactly as it should be done. We can overcome in our virtual worlds the limitations of a real world. We can, for instance, provide different views onto the same scene without us having to move. We can offer teleportation to quickly go from A to B without having to perform the many navigation steps that would otherwise be required. We should also always avoid fake 3D. 3D should serve a purpose. The bar chart that you see here has a third dimension. But this third dimension offers no information. It is just there to beautify the bar chart. It is thus completely useless. We should only use 3D when we need 3D. In multiplayer 3D worlds, we often represent ourselves and the other players as well through avatars. What typically happens is that people choose avatars that look very different from themselves. First-person games are very often performed in a virtual 3D world, giving you a sense of immersion into that world. When we design 3D interfaces, there's a number of aspects to consider. First of all, to give you a sense of reality, we should make correct use of occlusion, shadows, and perspective. Objects obscure our view onto objects that lie behind them. Lights cast shadows, and the scene needs to have perspective. And what is further away appears smaller than what is close by. We have to minimize the number of navigation steps. For instance, if we go from A to B in a straight line, one command should suffice to do that. We shouldn't actually be entering the individual steps. We sometimes need to give messages to the users. And to keep the sense of reality, that text needs to appear as if it plays a role inside the scene. It cannot be a simple dialogue box that pops up. But by embedding it in the scene, we have a problem to keep it readable, to be clearly distinguishable from the background, etc. Unless we really want it, we should avoid visual clutter. We should keep our environment simplified so that the users are not distracted from the main task at hand. Sometimes we want to simplify user movement. In online or offline 3D games, when you are moving about, it's very hard to control your direction precisely. So when you have to walk through a narrow corridor, the system should make it easy for you to walk in a straight line through that corridor and essentially correct for the small errors that you make. Sometimes we also want to simplify the object movement. When children who don't have precise motor control yet are trying to complete a puzzle, but when they move the pieces of the puzzle, we have to approximate the position where the pieces should be and consider it good enough. This is called docking. When you're close to the destination, we consider it good enough. Also use visual grouping so that items that belong together are grouped not with, say, rectangular boxes, but with elements that actually play a role in the scene. For enhanced 3D features, there are a few guidelines to follow. First of all, offer the possibility to give an overview. Offer a helicopter view onto the world so that you can see what the whole scene is, right? And not only see the close view that you have when you're inside that world. Allow teleportation to avoid a lot of navigation steps. Perhaps offer X-ray vision when it is useful to see through a wall rather than having to go around it. Also provide a history of actions so that you can replay a scene or go back a number of steps and then take a different course of action. Permit richer actions on objects than just picking them up and moving them. Maybe you want to rotate them, throw them, squeeze them, anything you can imagine. 3D interfaces can be used to enable remote collaboration, where there will be another side and you are not there, but you can visually and virtually interact with that other side. Offer also tools to mark and select objects and to perform measurements. When we're creating a 3D drawing, we may have drawn a line and then forget how long the line was. We should be able to measure it again. Also implement filters to show landmarks more clearly and to remove unwanted detail. We already know this from when people were creating geographical maps. When you have a map for a country you are going to visit, the roads are actually clearly emphasized. They are much wider on the map than they are in the real world. Right? And they are colored so that they stand out. And if, for instance, on Google Maps, you zoom in or zoom out, you will see that when you zoom in, additional objects start appearing on the map, additional detail becomes visible, and when you zoom out, that detail is deleted again. A nice application of 3D virtual worlds is teleoperation, where there is a real world somewhere else and you are going to work in that world from a remote site. So you see a virtual representation, but there is a real remote world. This exists, for instance, in the medical world, where the doctor you see here is actually, the doctor is sitting behind a screen, is looking into a viewfinder and is manipulating with his hands a set of virtual tools. The actual operation appears on the, is done on the operating table, where people are watching that everything is done correctly. And the movements of the surgeon may actually be scaled down to the movements of the tools operating on the patient. So in this case, the type of movements are the same, but they're just scaled. Now, sometimes we don't have that and have very different physical motion and control motion. For instance, nowadays, a lot of people are playing with these quadcopters. It's fun, but it's also hard to do because the motion you have to do is very different from the actual physical motion of the quadcopter flying through the air. You get some joysticks, and one joystick may control direction and the other joystick controls whether the quadcopter goes up or down. There is a steep learning curve, right, into flying such a quadcopter without having accidents, right, because your motion doesn't match the motion that you see of the quadcopter. In teleoperation, you also have to account for time delay. People trying to control the Mars rover have to take into account that when they issue a command, it takes 45 minutes to reach the rover, and then the rover is recording what happens, and it takes 45 minutes before you can actually see what happens. There may be incomplete feedback. You may not see exactly what happens at the other side. There may be some interference, there may be some noise, maybe some imprecision. There may also be some unanticipated interference, like when we saw the doctor doing this operation, there were people actually standing by the operating table, and they may interfere with what you're trying to control remotely. We also have a distinction between virtual and augmented reality. Virtual reality breaks the physical limitation of space and allows you to be somewhere else, but that somewhere else is a place that doesn't really exist. You are in rather than looking at that world, right? But it is all virtual. This has serious applications. For instance, in medical. People with vertigo can get a treatment using virtual reality where they're placed at the edge of a cliff, but the cliff isn't real. So you first have to control your fear and your posture and not fall off the virtual cliff before you are ready to go stand at the edge of a real cliff. In augmented reality, the real world that you see is actually real. And you see an overlay. LiDAR is one of the first commercial applications that is actually quite popular on mobile devices. So tourists will go explore a city, they look at a famous building, they point their phone at the building, and on the phone they will not only see a picture of the building taken by the phone, but they will see information overlaid on top of that virtual building. When we use virtual or augmented reality, we need a lot of devices to work with. The success of such an application depends on the good integration of all the different aspects. Like the display must be of good quality. It must follow your motion. So if you turn your head, the image should move instantly, right, with your head movement. You have hand position sensing using data gloves, and to have a feeling of reality, it needs to give force feedback. When we're trying to pick up a virtual object, we should feel that we're touching the object. There needs to be sound input and output, because we use all our senses, and the other sensations should all be there. Finally, we can also use virtual reality to collaborate with other people or to play against other people in a virtual world. Thank you for participating.